It really is nice having the radio's dial calibrated so that when you go to 10 megahertz you hear WWV. So it's worth doing the whole alignment on the radio once you've got it recapped, which I highly suggest. So in an earlier video, buried in the back was the restoration of an S-120 receiver. I've had several inquiries about the 120. This seems to be a very popular beginner's receiver, and quite a few of these are stashed in the attic or in the closet of some guys that would like to get them back on the air. So you'll find some YouTube videos showing how to work with the receiver. Two of them are here. One of them is the one I used in the video that I restored, and the other is a fresh one that somebody sent to me, and he wanted me to just go through it, and I said, I'll do it on one condition, that you let me do a video with receiver, and we'll do a dedicated S-120 restoration. Not really a restoration, but at least getting it back on the air safely and working effectively. So the first thing we have to do is obtain a few critical parts. And the most important part you need to get your hands on is this. It's a cut-off cord from an appliance. You know, it could be a hairdryer, or it could be an old boombox, but the nice thing about this plug is it's polarized. A two-prong polarized plug. This is what we're going to put on the radio for safety, and we're going to make sure that the neutral is attached to the larger prong. So this is an AC-DC set, meaning that there is potential for a shock, so we have to be very careful with the receiver so as not to come between hot of the line and ground. They have done some isolation in the design to make sure that the outside chassis is not actually connected to the cord ground, or the potential is reduced. Not completely eliminated, but it's greatly reduced with the receiver. Here's some parts that we need to get our hands on. It's more than likely that the electrolytic capacitors are going to be bad in the receiver. So you need to get some replacements for the electrolytics. You need to get your hands on some mylar capacitors or whatever you can find to replace some of the paper caps that are inside. And I like to put an inline fuse in the receiver inside in place of the fuse resistor, which is hooked up in series with the selenium rectifier. Put a real fuse in there. Finally, the selenium rectifier itself can be replaced with a 1 or a 2 or 3 amp high voltage diode. Now what we do not want to do is just immediately turn on the receiver. Even when we replace parts in the receiver, we want to use something like a small variac to bring the voltage up slowly, and the variac should have a fuse. This is one that was used on an old-fashioned soldering iron, and it's probably about a 75 watt unit. Perfect for bringing receivers up from the dead and reforming electrolytic capacitors. So keep your eye out for something like this if you see one at a hamfest. Now the service data is right online. I was able to download it, and this helps you should you have to restring the dial. Can be done with ordinary Dacron type fishing line used for ice fishing, for instance. That's a popular thing to try to use to restring these. Also, you will find the alignment procedure. It takes you through the alignment of the receiver and the location of the tubes and so on. This is very important when you're when you got the receiver all done. You definitely want to align it so that everything is right up to spec, and you can really pick up the broadcast band DX and the shortwave stations and so on. Also, we know that the BFO system in this receiver is not ideal. They essentially make the IF amplifier oscillate and self-oscillate into a BFO type of operation. But if it's aligned correctly, it's at least passable for some CW and single sideband reception. But this receiver was never meant to be a high-class single sideband receiver, that's for sure. So let's go step by step on the S-120 for a very simple restoration. We'll be using an isolation transformer and wash it down, get all that nicotine off the outside of the case. You know, these things have seen a lot of action through the years. Removing the panel in the back, and very carefully that ferrite rod antenna comes out of the snaps. If you can get away with not breaking that over the course of the restoration, that's a really good thing. Remove the feet because that's what holds the chassis in the case. Slide it out. Take a look. Wow, this one looks pretty clean. This is very encouraging. And take a good look. Now's the time to notice if somebody's replaced a cap or there's any tubes missing. You want to remove all those tubes, and we really would like to spray everything, get the contacts all cleaned on the tube sockets. Oh, do you notice the speaker's cracked or broken? If it isn't, it will be by the time you're done. Put something on there to guard that speaker. And here we've added an inline fuse holder. I just don't feel safe not having a fuse inside a radio. Good time to test all the tubes. Tubes are almost never bad. That's one great thing about radios. Generally, the most reliable part of these old receivers are the vacuum tubes that are inside. And just as a matter of course, I do like to test the tubes when you're bringing back a radio. And very strangely, I found that 2 of the tubes were not testing right on the small tube tester. So I brought out my big gun, my Precision, and double-checked the tubes. And sure enough, both tubes are testing bad. Extremely rare to have 1 tube bad in a radio, but to have 2. The only thing I can attribute it to is possibly something with the line, because it is a series string that put some stress or strain on the tubes and took them both out. Very, very odd. So this radio would never have worked with these tubes in it. So we haven't even done anything yet, and already we've probably found the major problem with the radio. Now's the time to oil all the bearings on the variables and put contact cleaner on the contacts on the variables. Get all those pulleys lubricated properly. And get some graphite possibly. So the S-120 seems to have a variety of both Black Cat and Black Beauty capacitors. And any one of those could be leaky and possibly cause problems. The most important ones are the ones that connect between the chassis ground and the ground return used for the AC-DC, where it could literally light up the chassis and get you in real trouble. So we'll be looking at the capacitors that are in the places that can cause safety issues. First, I'm going to be using an isolation transformer just for safety at first. I also see a selenium rectifier in there, and I will probably change that out to a diode, a silicon diode with a series resistor, so that we don't put too much voltage on the stages. The selenium rectifier has quite a bit of loss compared to a regular diode. So step 1 is just to get the radio back to its normal working condition. Give it a look over. Oh, look at those! Look at that pretty electrolytic replacement job. That's not bad. Lots of tape, good insulation. Okay, I see a lot of Black Beauty capacitors. Excellent. So you may be wondering, is this a restoration or is this a modification? This is a restoration. In other words, we're putting the radio back into operating condition without doing any modifications other than those that are warranted through something wearing out or safety issues. That's it. Improving this receiver to the point where it's even good enough to be used as a novice receiver is very questionable. This is an entry-level receiver, mostly used for shortwave listening, and that's it. the BFO is really a joke in this receiver. The AGC is quite primitive, and I don't think you can ever get the hum out of it without some pretty radical modifications. It is what it is, and it does a very good job as an entry-level shortwave receiver. So there has been a lot of controversy as to whether the S-120 and its kind are actually connecting one side of the power cord to ground, to chassis. Chassis. Okay, let's talk about chassis. What is chassis? This is the chassis. This is what we call the chassis. Now ground, on the other hand, is the AC ground for all of the circuits. When we talk about RF circuits, audio circuits, the AC ground is floating in this radio. So if you are to use a ohm meter, I'll just prop the ohm meter up here so maybe we can see it, and we measure from one side of the cord to the chassis. Okay, what we're going to find is that we have a half a meg, 552K. Now, if you look at the schematic, you can see right here that they are indeed tying the chassis to ground through a 470K resistor and a 0047 600 volt capacitor. So that is the connection between chassis and ground, and that's a safety measure. Now if that capacitor should short out, now the cord will be connected directly to the chassis, and it would be a big shock hazard. But there is a safety system in here. Now they also have this back panel, and people claim this protects you from touching the chassis, so that's another way of protecting you. Well, not really, because the front panel and everything else, it basically can accidentally come in contact with the chassis. They put a little fiber board here to try to disconnect the front panel from the chassis, and there's another, that's, you know, just another attempt at safety. So there's some paint on the chassis. That paint is another way to protect you from getting a shock. All of these are kind of weak safety measures. So what a lot of people like to do is they like to replace the plug it happens to come with a polarized plug, and convince themselves that by plugging it in with a polarized plug, that's going to give additional safety. So really the most important thing with this radio as far as safety goes is to replace those capacitors, specifically C29, the 0.0447, with a new capacitor that has at least a 600 volt rating, and that would be the best thing to protecting yourself. If you want to go as far as to use an isolation transformer, that would be a good idea too. But this receiver is completely safe as long as the capacitors are in good condition. I don't see anything wrong with the way that they have this hooked up. It looks like they are attempting to switch the one side of the line through the switch. I don't have any problem with that. And one side of the line is connected to ground immediately. That could be useful because we could probably put a neon bulb and a resistor in there, and that might be useful to tell if you are hooked up to neutral. If you were to put in a 3-wire cord, you could at least have a safety system that would alert you that the line is putting the hot onto the side that goes through that 470K to the actual chassis. So if we want to go as far as to do a 3-wire cord, we could add a neon bulb in there that would alert you to an outlet that's not wired properly. I don't think it's worth doing all that. Maybe putting in a polarized plug is a good safety measure as long as you know that the plugs are wired correctly, or you buzz it out and you make sure that the radio stays plugged into the same outlet all the time. But The real protection is the separation of the chassis ground from the AC ground in the radio. Okay, so I have plugged in the receiver. We have wired the cord correctly. And what we're going to measure is the potential between the chassis and a solid earth ground. I have the meter in the AC volts. Let's just measure. Should be a cold chassis. 121 volts. Okay, so what that tells you is that the outlet is wired wrong, even though we've taken every precaution to wire the AC cord properly. The chassis is nevertheless hot. Now, we are protected by the 470K resistor and the 0047 capacitor, and that will limit the current. But you still have some voltage there, and you will feel certainly a tickle if you get across that. Now let's look at the chassis, which is supposed to be isolated. I see some fiberboard there between the actual front panel and the chassis. Let's measure to ground. Oh, looks like we have 68 volts there. So our isolation's not as good as we thought. So just keep in mind you're dealing with a quote-unquote hot chassis radio, and of course we always have to suggest that you use an isolation transformer with these receivers. So I'm going to assume that by now you've recapped the radio, you've got the power situation under control, and you're getting ready to align it. The alignment on this radio is a little bit more complicated than any All-American 5, really. You have essentially an All-American 5 that's been turned into a shortwave receiver, so there's not much to it. You don't need to build the fancy network to attach to the antenna terminals. You can just use coax out of your generator, but make sure that the ground of the generator and the ground of the radio are at the same potential, or at least there's not a danger situation. First, we're going to align the IF, and we're just going to set up the generator to come straight into the antenna. We don't need to hook up to anything special on the radio. We can use the regular antenna terminals and inject right through the mixer like it's not even there. You'll need a 30% AM type signal. Now as you work through each band, remember that the trimmer affects the top end of the band, the slug affects the low side of the band. By jockeying these two controls, you can get the scale to read correctly from one end of the slide rule to the other. It really is an easy receiver to align, and other than problems with images, it's quite a good receiver, at least until you get to very strong signals or very high frequencies. So as with any receiver, keep reducing the generator in amplitude as you go through the stages and peak them, and repeat the process a few times until you're happy with your dial scale and your sensitivity across the band. Also, the BFO is not going to work right. Basically set it at about 1 o'clock and then adjust the top of that transformer, and it will go into oscillation at some point when you get the phasing right. It will not markedly cause the IF to be untuned, but it will slightly untune the IF. That's how that crazy BFO circuit works, and how they tempt the IF to actually oscillate. So this is the Marine band. Now the BFO on this thing, it's not a great BFO, that's for sure. Not exactly the receiver you'd want to use to listen to W1AW code practice.
You know, we would be out. Me and Clark started the QSO like hours ago, man. we have been out here occupying this frequency, and they only fired up not that long ago. If I'm making that big a splash down there, then yeah, I'm gonna go ahead and say it. Those guys are jerks.
Are you saying that those guys are jerks?
I'm saying that, well, really what I'm saying is those guys are jerks.
So I think that covers the receiver quite well, and I think the series that this represents, starting with the early S38s up through the S-120, they're well worth restoring, and they're not widow makers or killers. If you treat them right, you can put them back on the bench successfully, and they'll give you a lot of fun listening to shortwave and amateur radio broadcasts.